All right. Well, good morning, good afternoon, or good evening, depending on where you are located. And thank you for joining us this morning, this afternoon, in the webcast from the Windows Developer Tab program today. So I hope you're all safe, you're all healthy, and you're all good. And first of all, thank you everyone who responded to the survey that we sent out about which topics we wanted to hear about us and which were relevant for you. So basically, today's webcast is based on your feedback about the main technologies that you wanted to hear from us, that you wanted to learn. So thank you so much for participating in the survey. And we will continue to send similar surveys in the future to learn more about what your top priorities are and requirements. So please keep participating. I want to take advantage as well of today's webcast to let you know that we are hosting two types of webcasts within the Developer Tab program. One type of webcast to talk about technology that we have released and that you can use right now in your production environment. So basically, today's webcast is around those type of technologies. And then we will also plan to have a second type of webcast, which is about technologies that we are having only in a design mode or in a pre-release mode. And for those, we want to get your feedback before we even release or start coding the actual feature. So we will let you know in advance which type of webcast we are hosting, so you can participate in the technologies that are relevant for your area. So today we have a very special guest, or I should say guests. They are our App Consult team, which some of you might have already worked with. They will be talking about technologies available to help optimize your Windows desktop applications. For those of you who are not familiar with our colleagues from the Windows App Consult team, they are a team of premier field engineers that are distributed globally across different regions, and they partner with Windows developers and companies such as yourselves in their journey to optimize their applications using the latest developer features in Windows 10. App Consult is expert in technologies such as MSIX, ML Islands, .NET Core 3, and so much more. And all these technologies are covered under the Windows Developer Platform. So App Consult can provide support for your projects and can provide technical assistance, workshops, or sample codes. If by the end of the webcast, you want to learn more about a specific technology, or you want to take advantage of them within a project that you're driving, please do let us know. Please reach out either by Yammer after we end up the session, or by Teams, or even by email. So having said that, I will hand it over to our App Consult team. Let me introduce you to Mike Francis, who is a PFE based in the US, Matteo Pagani, who is a PFE based in Italy, and Sebastien Bovo, who is a PFE based in France. So here you go, Francis.
Great, thanks, Jesus. So I'm going to be talking about modernizing your WinForms and WPF applications with .NET Core and Windows 10. And again, this is one of the most popular topics that you, as participants in the TAP program, wanted more information about. So I'm going to hit on a couple of, I'm going to update some of the important announcements and milestones with respect to the frameworks that you use in your WinForms and WPF apps. And I know that you've likely heard this before, but I just want to hit on the important points and also update you on developments there. So .NET Framework 4.8, this was released almost a year ago now, and it's available through Windows Update. And this includes accessibility improvements in WinForms and WPF, high DPI support, and it was last updated in the summer, just this last summer. The important thing to know about the .NET 4.8 is that it's the last framework that is the .NET framework that will have new features. So going forward, it's in maintenance, and it will receive regular updates with respect to security and maintenance. And if you don't know, you can find everything .NET related at net.microsoft.com. So the successor to the .NET framework is .NET Core, or .NET Core, and so 3.0 has been out for a while, and the latest version is 3.1.3, which was just released a couple of weeks ago now, March 24th of this year, so the end of last month. A big thing that's important for us as desktop developers is the support for WPF and WinForms applications. And a big feature of .NET Core is its side-by-side support as well as self-contained support. So you can package up the runtime all within your application, and you don't have the worry or the concern of making sure that the target framework is available on the machine that your app is being deployed to. That you could package up the runtime with the application. So this is, we now have full stack development on the server with C# and Razor, as well for web development, and you can use share libraries between your server web development and also on the client. There's a significant performance improvements over the .NET framework, and additionally, you could take advantage of new language features like C#, C#8, which is not supported in the .NET framework. So there's been some developments in .NET 5. So the preview 2 just came out on April 2nd. And so .NET 5 will be the version of .NET actually when it ships, or when it's generally available, it will be just referred to as .NET. And that's building on 3.0, so everything that you have in 3.0 plus the best of Mono, and you'll have a single platform for all of your .NET code, including Xamarin. So Xamarin will be a new app model that's supported there. Also, if you're do anything with Entity Framework, that's also available in preview as part of the download for the .NET 5 preview. Important thing to point out about .NET 5 preview 2 is that it does not yet support WPF and WinForms apps, so that's pretty important. So you might want to hold off for your WPF and WinForms apps with .NET 5, but stay tuned. Check back regularly because of course that's coming. And just to kind of, you've likely seen this schedule before, and to kind of reiterate the schedule, the team's still on time to ship .NET 5 or .NET in November of this year. So a couple of new tools, if you haven't heard, is that one of the things kind of missing with .NET Core 3 for WinForms was the lack of a designer. And so that's available now in preview form in Visual Studio 2019. There's a preview 16.6, preview 1. And you can download that at visualstudio.microsoft.com, VS preview. And another tool that one of our colleagues shared with the team and has proved very useful is this .NET Core uninstall tool. Because likely you're experimenting with these different versions of .NET and .NET Core, and over time they just accumulate on your drive, and right. So I had about 5 versions that I wasn't using where this tool was very handy to uninstall. So that's at aka.ms.net-core-uninstall-tool. So feedback also, you know that WPF and WinForms are now open source. So, and the team is always looking for feedback. So, and as we're any questions, or especially issues that you're running into using WPF and WinForms in these new contexts that we'll be talking about here. Definitely, the team wants your feedback, and they're pretty responsive there. So please check that out. All right, so upgrading your .NET your .NET desktop apps. So you have your WinForms or your WPF app, and you want to actually, you've probably seen the great features that have been available for UWP apps. And many of those features have not been available to include in your WinForms and WPF apps, and that's changing in a big way. So, in fact, one of the goals for the team is to really remove kind of the distinctions between these apps from a developer point of view. That is, if there's a feature that you want, you should be able to use it in WinForms and WPF just like you use it in UWP. So and so the thought should be, I'm not writing a WinForms app or a WPF. I'm writing a Windows app for and targeting Windows 10. So, and basically you have 3 UI frameworks for the desktop. That's WPF, WinForms, and WinUI, which is basically the UWP controls. So upgrading your .NET desktop apps. So what does that mean? Now, before all of this work the team was doing, basically to upgrade your WPF or WinForms app, you had to pretty much rewrite it to UWP, and that there wasn't a lot of uptake on that kind of ask for developers. So instead, or the team went back, and now many of the features that are available in UWP are now available for WPF and WinForms apps. So upgrading in this context means bringing many of the features of UWP to WinForms and WPF. So when we talk about upgrades, we talk about using a modern runtime, a runtime that is cross-platform and can take advantage of new language features like that's .NET Core and .NET 5, and already with .NET Core 3 that takes advantage of C# 8, which is not available in the .NET framework. Another thing that you want to take advantage of Windows Runtime APIs, which was you could do it, but you needed to bring in a lot of libraries and metadata files and so on. So that's been made much easier, and I'll show you a demo about how that works. Whoops, sorry, we're getting jumping ahead on the slides here. Sorry about that. I'm not sure what happened. Okay, so also having a modern and accessible UI and input. So now there has been a lot of improvements in Windows 10 with respect to accessibility and input. For example, with inking and with touch support. Those have been big features of Windows 10, and WPF and WinForms really aren't optimized for those input types. That has changed with this technology called XAML Islands, which allows you to host UWP controls inside a WPF or WinForms application. So you can add an ink control, ink canvas control into your WPF app to give inking support to to your WPF, and that's right. I'm saying that as an example. Basically, just about any control that's in WinUI, you can host that in your WinForms or WPF application. Seamless app deployment, updates and optimized for DevOps. So this has to do with MSIX packaging, and the whole kind of exercise around, as a developer, you have to decide on your update kind of mechanism. You have to maintain that mechanism. So maybe you go with click once, maybe you have some other, maybe using Squirrel is another popular distribution mechanism. By going with MSIX, that is a lot of those tasks are taken care of for you. And so with MSIX, it supports automatic updates, incremental updates, which is where only the bits that change between updates are sent across the wire. Rollback is now supported, so you can go back a version. Also, mandatory updates are also supported. So if you want an app to block until an update is installed, that's supported as well. .NET Core has built into it support for CLI acquisition and updates for more efficient DevOps support. And then finally, the agility to innovate at the developer pace. So because of the side-by-side and the self-contained distribution that's included with .NET Core 3, you're not bound to a specific version of the framework, being available on a target machine, or basically, getting that dependency installed on the target machine. That goes away, so you can really develop more at your own pace. So to give you an example, so one of the things that I mentioned is the performance improvements with .NET Core 3. So I'm going to go over here to my demo desktop. I'm going to start. I have an app here. It's called PySample, and it's a just one sec. Here we go. It is a WinForms app. And it's just a kind of a plain vanilla WinForms app, and what it does, it enumerates files. So there it is. And also, so I'm going to point this at my OneDrive just because I have a lot of files there. I'm going to copy this because I'm going to need it again. Now I'm going to run it. Now while that's running, I'm going to start this again, and this time I'm going to swap out the runtime for .NET Core instead of the .NET framework. My this app is built against the .NET framework, so I'll do .NET pysample.exe. So now there's another component to this. There's a configuration file which I'll show you when we jump back to the slides. So I'm going to also point this at my OneDrive, and I'm going to run it. I'm going to put that over here, and I will snap this over here. So over here on the left is the .NET Framework application, and over here is a .NET Core. And we can see here that we go down to the bottom right of the apps, and we can see that this took over 2 seconds to run. And then with .NET Core, this took less than 1 second to run. So kind of right off the bat, if you need some kind of proof point as far as performance improvements, I was able to do that without it touching the code at all. Just running it with, as you saw with .NET, that swapped out the runtime. If I go back here, I'll show you the. Let me see. Yeah, so here is the configuration file. So if you remember, the app is called PySample. So it's pysample.runtimeconfig.json. And this is, of course, all documented, but here you can see you could specify the framework and the version that you want the app run against. And again, this is really just for testing purposes. This is not, we're not porting the app at all. You would have to go in and actually do the work to have it use the new the .NET Core APIs. And so kind of to set your expectations when moving to .NET Core, that you'll find runtime optimizations. You'll most notice those with file I/O, like I showed in the demo there, networking and database operations. And then for you may not see performance benefits in UI rendering or startup time. Those should be the same. So another great feature is the ability for what you would like to do in your WPF and WinForms apps is take advantage of these Windows runtime APIs. And a popular example, let me close these here, is you want to add notifications to your application. So I have a sample app here, and this is a WPF application. Let's see. Still there we go. Okay, so what let's have a scenario where my boss says, hey, yeah, we need to integrate with the Windows notification system, and we want to, that works well. We want to take advantage of the Action Center. Here's the Action Centers down here on the right. I just clicked on the icon in the bottom right. That pops up and shows me the notifications there that I can, review and take action on as needed. So what I'm doing here is I'm going to add in this code. Print this out. There we go. And so, right, and you could find this. There's lots of samples like this available. But when I include it, right, it's saying that it's not. I need to include a library to reconcile these. So the library, the NuGet package you can use to get access to the Windows runtime APIs is called Microsoft.windows.sdk.contracts. So we'll click on that and we'll install it here. And I'm going to accept. And this should go quickly. And so now if I would go down to here, and if so it's now prompting me, suggesting that I include the windows.ui.notifications namespace. So we'll do that. And then that all gets resolved now. So if we run it, and this should compile quickly. Oh, one thing now, yeah. So actually, this won't work as is because notifications require an app identity. In fact, I should get a crash here. Yeah. So that's fine. We just need to add an app identity. So here to do that, we need to package it with the Windows application project. So I'm going to do add new project. I'm going to do packaging, Windows application packaging project, kind of a long name. I'm going to add that there and accept all the defaults and the default project name. So now I'm going to right click on this applications node, add reference, and then I'm just going to add my WPF application to that. So if I drop this down, I can see it's now being referenced. That's good. Now I'm going to make this the startup project, and we're going to run it again. So this is going to run the app in this MSIX context which is cool in that you can actually debug the app in either outside of the MSI context, either outside or inside. So right now it's running inside. It's also providing an app identity. So now when we click this, let's see one more time. Not sure what's going on. Oh, I have, you know what, for this presentation, I blocked notifications. So here, yeah, here, I was clicking it 3 times and there's the 3 notifications. So you can see that we just didn't see it pop up because I'm using the feature of Windows that allows me to suppress notifications. So that bit me a little bit, but we can still see that they appeared here in Notification Center. So again, I'm using Windows Runtime APIs in my WPF application, and I have this NuGet package really made that easy. Microsoft.windows.sdk.contracts. So I mentioned modern and accessible UI and input. So a good example of that, if you go over to the Windows Community Toolkit sample, this has it's a great demo for controls that are part of the community toolkit. And in that toolkit, they have wrapped several of the controls in the I haven't mentioned this yet, but in basically XAML Island host controls. So you can take these from the toolkit and include those into your application. If for custom controls, you have to host them yourself inside the XAML host control, but here in the toolkit, that has been done for you. And if you haven't seen this is an example of taking an ink canvas control, and it's wrapped in a XAML host, and then it has the sample XAML and really good, pretty complete documentation on using this UWP control inside your a WPF or WinForms application. So there's ink canvas, ink toolbar, map control, media player element, web view, another web view. I'm not sure what that one is, but you kind of get the idea. So definitely, if you want to start using these controls in your WPF and WinForms apps, definitely check out the Windows Community Toolkit. And I didn't actually show you this in code, but another NuGet package that has a lot of helper functions, and these wrapped controls are available in the NuGet package Microsoft Toolkit WPF UI.controls. And so I did mention briefly, so that is using the current XAML Islands technology, which uses window handles to communicate between the OS and the app code. Now one thing to be conscious of is that it's supported on Windows 10 1903 and up, and that might be a limitation. It is a limitation for often you need to support earlier versions of the OS, and that's actually coming in WinUI 3. WinUI 3, and I don't want to go into it too much because my colleague Sebastien will talk about that here in the next segment. But it basically will have that hosting will be built in that is the XAML host will be built into WinUI 3, so you don't have to manually or do this kind of intermediate step of having the host and then have the control inside the host. That'll be taken care of, and that will be supported going back as far as 1703 or Windows 10 1703. So quite a few more versions of the operating system will be supported in WinUI 3 when that becomes available. So speaking of WinUI 3 and Sebastien Bovo, I will transfer. He's going to take control now. And Sebastien, why don't you tell us about WinUI 3?
So it's my turn. Thank you, Mike, for the first part of this session. So .NET Core 3 was a way to first modernize your existing desktop application using the brand new .NET Core framework, but we can go further and specifically work on the UI using WinUI 3. And it is about using the new XAML platform WinUI 3 inside desktop application and also a WP application. So what we want to do with WinUI 3, it's about decoupling the XAML platform from the OS. Mike just show you that XAML Island is a way to use Windows 10 UI and controls inside existing desktop application. So it's tied to the system. So we use the XAML platform from the system, from the operating system to any kind of application. With WinUI 3, we want to decouple this XAML presentation framework out of the system to make an entirely new out-of-band component in order to be not linked to the specific Windows 10 version, but to be able to run it on of Windows 10. And of WinUI, new control, new bug system. Yeah?
Sorry, I think it's just me, but you're cutting off, so maybe you want to stop sharing the video.
Okay, let me stop the video on the team. I wish it could be okay for the voice. Let me know if we have got any
that
issue.
sounds much better now. Yeah, sorry.
Thank you. So the goal is to really have WinUI, the XAML platform out of the OS and be able to use it with out-of-band components and be able to ship it more quickly than the OS release twice a year. So Mike just explained, right now you can use all the Windows 10 XAML platform with XAML Island, either in Win32, C++, or .NET application. You can build your own controls. You can use WinUI 2, which is a bunch of control provided by the community toolkit and other stuff. But underlining, we use the Windows 10 XAML platform for being able to display the control, to provide animation and everything. And we are tied to the latest 19.03 version, starting for this version and later. With WinUI 3, we want to decouple and make all the XAML platform, all the presentation layer out of Windows. And we will re-architecture this XAML platform to make it available on older version of Windows 10 until the version 1703. Of course, the displays, the animation will have the same behavior in all platforms because we could use newer feature on newer version, but all the controls, all the APIs for presentation will be available on older version. Don't mistaken, WinUI 3 is just about the UI framework. the presentation, the controls, the animation, everything. It's about the namespace like windows.ui.xaml, windows.ui.input, or windows.ui.composition. So this is only a part of all the APIs from WinRT, and all the APIs are just part of the AWP platform, which contain also the packagings API, the way to activate or to use WinRT component. More important, the way that the application behaves in the operating system, which is much more different than Win32. We run in app container, we have capabilities, the application can be suspended and resume, and this change a lot. So what is our goal with WinUI 3? Is to decouple all the XAML platform out of Windows and to make it available for WP, of course, and for also Win32, no matter if it is .NET or C++ in WinForm or WPF. And we want to include in this the way that we will provide the island that Mike talked about inside the WinUI, so you do not have to worry about doing extra code to support island. So this brings some challenges because, for example, the most important is about the windowing infrastructure. You know that in Win32 we are dealing with HWinMDs for Windows, and on AWP we are got some kind of abstract interface or object like core windows. Basically, it's just one unique window. Of course, we provide several sub windows for application, but this difference is a huge challenge for being able to provide WinUI for both platforms, because some API are specific. Some XAML APIs are specific to AWP. Also, for the input system, we develop a brand new input system for AWP, which is core input to deal with touch, pen, mouse, and everything, which is different from the Win32 input mechanism. And also, I talk about the life cycle. On Win32, an application is launched and is shut down when the user click on the right cross on the top right. But for AWP, the application is launched in full screen. If we reduce it, then it will be suspended, so not running. It can be resumed. So we do not control the lifestyle of the application. So all these challenges are we have to take care about in WinUI 3, because in all the presentation layer, the XAML platform, as it was designed for AWP, we are calling APIs like get for current view or application view, which are specific to the XAML platform. So the purpose of this is to do a UI layer, like a facade, to write the same code for both AWP and Win32. So at this point, you will say, okay, if I can do the same UI, the same controls, the same API for the presentation in AWP or Win32, what technology I would use? Mike told you that using the NuGet package, you can call AWP APIs from Win32. On the other hand, on AWP, we can call Win32 components. So it's not a matter of which API you can use on which platform. It's not a matter of which control, Windows 10 control, Windows 10 animation, composition we can use on each platform. It's just a matter of choosing the app model you would like for your application. For example, you want to run on multiple devices, on Xbox, on Surface Hub, you will go for AWP. You want to run on desktop, you can stay in WPF, Windows Form, C++, Win32. You want to use the capabilities you want to reduce battery consumption because the app will be resumed and suspended depending on the user use the app or not, you will go for OWP. If you want to use the native classical Windows API for accessing all file system, do what you want on the OS, maybe you will go for Windows 32. So the choice is not about the APIs you can use, but more about the app model. So WinUI 3, we do not want to reinvent everything. There will not be 2 versions of WinUI 3. There will be only 1 version. This version will behave like one unique point to be called either for Win32 and AWP, but we will not have different implementation of WinUI 3. And to achieve this, as I told you, we have to overcome some challenges like the windowing challenging. So maybe we still a work in progress. We will provide some top level object like XAML Windows, XAML application to be able to provide you high level classes and write your code in the way that you do not care about if you are targeting a Win32 app model or a WP app model. The goal is to be able to write the same code no matter on the platform we are running. We are not sure at 100% that we will be able to write one unique code for every single API for the presentation, but it's the goal. We have to continue the work. We will provide you some beta soon, maybe around build or later. Keep in touch with the YAML group to be able to follow the roadmap or the GitHub. I will give you the link at the end. But it's not 100% sure because of the challenges. So to give you some way to have maintenance or modernize your existing application, you have several possibilities. If you are in maintenance mode for existing application, just use the Windows Form, WPF or WP control like you are using. If you are modernizing an existing application, of course you can use WPF or Windows Form in .NET Core because it's fully available. It will be compatible and will be supported. But if you want to include all the Windows 10 UI layer, you can use WinUI 3 with the same concept as the island that Mike introduced. But it will be just hidden for you. You will just use the WinUI 3 control like the one native control. And if you go to a new app, WinUI 3 would be the best path to use all the controls, all the APIs for the presentation in any kind of platform, AWP, with C++, .NET in Win32, because we will be able to add new feature to evolve the WinUI control sense API over the time. To give you a small roadmap, so XAML Island version 1 is the one which was introduced in the 1903 version of Windows. It's linked to the OS because the operating system provides the XAML Island infrastructure. So saying that, we will not have a XAML Island version 2 because we do not want to have the operating system providing the XAML platform to the application. We go directly to WinUI with Island if we are using existing controls in Win32. And the WinUI will take all work we did with XAML Island, and we will start to add new feature, new functionality. And this for any kind of application running on the Win32 or WP world. What we want to achieve is to not be in this situation anymore. I mean, if you have got an existing Win32 application in C++, to be able to use the Windows 10 controls you develop, you have to reference another WP application in C++, write your control, your code, add some manual reference, maybe deal with some activation issue or taking care of Windows events. So it's not so easy. We want to get right about all this. Of course, there are some helper in the community toolkit that Mike showed you, but we still have some work to do. WinUI will take care about this for you, and you will just have to use the NuGet package to be able to use the control in the XAML and in the code. So last slide, and I will show you what we are today. We still a work in progress. We are still decoupling the APIs from the operating system to make it standalone. We are moving to GitHub, we'll make it public later. And we have still a lot of things to do to deal with the app model to make WinUI compatible with both worlds. So you will have the slide in the YAML. You will have the world map, which is public right now. At the moment of speaking, we provide some templates to be able to use the alpha version of WinUI 3 in AWP only. The desktop part of WinUI is not yet available. And we provide also all the source code, and you can look at it and compile it to look at all the WinUI 3 controls we provide. Let me show you this application and this template to finish this part of the session. So I opened the public project for the XAML control library. You will see all the pages, all the control, and it's used in the reference the WinUI NuGet package, WinUI 3 alpha, and you see, for example, to use the control for WinUI is just a bunch of XAML, just using for example, the control picker with some property. For the navigation view, for example, is just some classical XAML. So I am in the WP C# application, so I can run this, and you can do the same on your computer. Is the XAML control library public project. So I was looking at the navigation view, for example, the navigation view control. So I'm debugging this application, and you can see the XAML I just show you with the navigation menu on top. You have got the sample over there. Just another example, for example, the reach edit box, which is over there. So just one tag in the XAML. Of course, you can write some extra code, for example, to be able to display some button in the command file layout. If we right click on some text, so let's go back to this. This is, sorry, I will try to put some emoticons, so I can just copy paste and click on this, and this are the right click enable, so I can just use the share button to invoke the new command added. Last thing I wanted to show you, if you install the alpha version of WinUI, you have a new template, and you can start creating a new WP application or class library or component with WinUI enabled. So just go on this link to be able to use the template and look at the controls in the XAML controls library application. So we saw .NET Core for modernizing application. We saw WinUI 3 to be able to use all the Windows 10 control and implementation layer. But all this will be maybe useless if we cannot use some DevOps way to build and publish applications. So Matteo will show you this right now.
Okay, so thanks, Sebastien. I hope everyone can hear me just fine. So as Sebastien has said, we have seen a lot of great technologies so far, .NET Core, WinUI, app modernization, but if you can't find a way to deliver these new features to your customers, it's useless. Because if your customers are stuck on all the versions, they can't leverage all the greatest enhancements that you made to your application. So the goal of this last part of this presentation is to show you how you can be more agile and enable a DevOps mindset, a DevOps approach for your desktop application. If you are a software developer, this slide shouldn't be a surprise. There are a lot of studies, a lot of researches which prove that there's value in adopting DevOps. You can reach the market faster, you can address feedback quicker. They told me I'm not sharing my screen. Okay, I hope now everyone can see it. Okay, so as I was saying, now you with the DevOps, you can reach the market faster, so you can get increased revenues, you can address feedbacks and bugs in a quicker way. Overall, you can deliver value faster and in a better way to your customers. However, usually when we talk about DevOps, we talk about it in the context of web, cloud, backend projects. And the reason is that in this world, enabling continuous integration and continuous deployment is relatively easy because typically these projects have a single entry point, like an HTTP URL. So it's easy to have a continuous deployment pipeline which deploys the output of a continuous integration pipeline to a testing environment, a QA environment, a production environment. With desktop application, with Windows application, this instead can be a challenge because let's say that you have 1 million of customers, 1 million of devices where your application is running. You have to update all 1 million of these devices to the latest version of the application. So doing DevOps for doing continuous integration and continuous deployment for desktop application might be more challenging. Enabling this approach, this agile approach for desktop application is made by different steps. In this session, I don't have enough time to cover all of them, so I decided to focus on 3 of them: packaging, distribution, and signing. The other ones are equally important, but they are not as specific for desktop application. For example, choosing the right build agent or doing versioning in the right way, it's important even for a web project or a cloud project. Packaging, distribution, and signing, instead, it's something which is specific for desktop application. Let's start from the packaging and let's talk about MSIX. Mike already mentioned MSIX, and it's you should know probably that it's one packaging technology, one deployment technology that we have introduced in Windows 10 with the goal to solve some of the problems, some of the pain points that the various actors involved in packaging and application deployment are facing. So when it comes to IT pros, MSIX enable application updates and enterprise customizations to be decoupled. So this means that also enterprises can deploy and release updates in a faster way. For users, MSIX is built with the premise never regret installing an application. So it provides a way to install application which is trusted, which enables a clean install and uninstall experience, and so on. For developers, it's a simple packaging format because it's nothing more than a compressed file with your binaries and an XML file called app manifest, which describes the identity, the versioning, and so on. And the main difference between MSIX and other installer technologies is that it's built in Windows 10. So you get for free some optimization like disk space, differential updates, without having to do anything special. You can deploy any kind of application with MSIX. Of course, we have MSIX support for the Microsoft technologies. So you can use MSIX with UWP, .NET Framework, .NET Core 3. But overall, MSIX is just a package around your binaries, your Win32 application. So it works just fine also if your application is Java, Electron, MFC, any kind of Win32 technology. With MSIX, you can publish anywhere, so you can leverage managed environments like the store for business, Intune, SSCM, but you can publish also your MSIX packages through unmanaged scenarios, like sharing your package on a web location or a network share. In the context of .NET Core 3, which Mike has introduced for desktop application, MSIX supports all the .NET Core deployment modes. So you can have a bigger MSIX package with the .NET Core runtime included, the self-contained approach, or you can build a smaller MSIX package, which is framework dependent and requires the user to have the runtime on his machine. There are multiple ways to create MSIX packages. As Microsoft, we offer the MSIX packaging tool. All the major installer authoring tools have MSIX support. But if you are a developer and you are building your application with Visual Studio, the best way to create an MSIX package out from your application is keep using Visual Studio. You will find a template called the Windows Application Packaging Project, which gives you a series of benefits. Mike has already talked about this project in his section. For example, you have the manifest editor, you have a debugging experience, you have a wizard to create the packages. But most of all, in the DevOps context, the best advantage of the packaging project is that it's based on MS Build. So this means that when you want to generate an MSIX package, you just need to run a Visual Studio build. This is a huge difference compared to other technologies where you need to install third-party tools, special Visual Studio extensions. So this kind of requirements might become a blocker when you want to use one of the agents provided by the major DevOps provider. Azure DevOps and GitHub, for example, they both provide Windows hosted agents, which comes with Visual Studio, the Windows 10 SDK. So you have everything you need to generate an MSIX package. If you want to use another technology, you might need to install other tools on these hosted agents. In some cases, you can't achieve this goal, so you are forced to use a private agent, so your own machine that you need to maintain. With the Windows Application Packaging Project, instead, it's safe to use the agents provided by Microsoft or GitHub because they have all you need to generate an MSIX package. Let's see the packaging project in action. So here I have a Visual Studio project with a WPF application running on top of .NET Core. And if I want to add a packaging project, I just need to add to this solution a project which type is Windows Application Packaging Project. This project is already included in my solution, and as you can see, it doesn't contain any code. It contains a manifest. It contains some default assets, which are used for the various icons and tiles. And instead of the reference sections, as a section called applications. From here, I have to choose among the various projects which are part of my solution, which one contains the application I want to package. In this case, it's the project called Contoso Expenses, so I just select it and that's it. Now, if I want to generate an MSIX package out of this project, I just need to right-click on the project, choose Publish, Create App Packages, and from here, I can start the wizard to generate the package. So I can do, let's try it again. Sometimes you get this issue. Okay, you start the wizard, and from here, you can generate a package for the Microsoft Store, for side loading. You can choose which certificate you want to use to sign the package. You can choose which CPU architectures you want to support, and so on. Since the packaging project requires only a Visual Studio build to generate the MSIX package, we can see that how this makes easier to generate a build pipeline. So a pipeline that takes my code and generates an MSIX package every time I do commits. So here I have a build pipeline, which is a continuous integration pipeline. It means that every time I commit new code to the repository, I generate a new MSIX package. There are various tasks in this pipeline. This pipeline is started from the Universal Windows Platform template. So when you create a new pipeline in Azure DevOps, you are asked which repository is hosting your code. And then Azure DevOps will scan the repository to find which are the best templates based on the code. One of the choices is a Universal Windows Platform, and this one will create a template with everything you need. My template might look complex because I have a lot of tasks. This is a YAML pipeline, but these tasks are for side activities. For example, setting the right version or running a diagnostic of the project to see if I'm using any package which might contain some vulnerabilities and so on. But the core of the pipeline is just this task, the Visual Studio build task. As you can see, it's nothing more than a Visual Studio build with already set some arguments which are used to generate the MSIX package. This is all I need to generate an MSIX package as part of my build pipeline. So this is enough to make sure that every time I add some new code or I commit some changes to my repository, I will get a new MSIX package as artifact of the pipeline. Another important aspect of the pipeline is how can I distribute the MSIX artifact that I generate as part of my continuous integration pipeline. So there are multiple options. If you are building an application for consumers or generally speaking for a wide audience, the Microsoft Store is a good fit because it's already built in every Windows 10 machine. So every one of your customers who is running Windows 10 will have the store. The store takes care of you of the signing process. So you don't have to take care about finding the right certificate to sign the application, because during the ingestion process on the store, Microsoft will sign the application, the package, with a certificate which is already trusted by every Windows 10 machine. The store also supports some nice features for developers like flighting, if you want to release different versions of the same package to different users. For example, if you have a set of beta testers. And in terms of enabling a continuous deployment story, the store is a great fit because it has automatic updates turned on by default. So out of the box, the vast majority of your users will automatically get a new version of your application every time you publish a new update. However, we know that the store is not a good fit for everyone. For example, some enterprises scenario. So we enable MSIX to be deployed also through other channels like a website or a network share. In this case, it's up to you to sign the package with a trusted certificate, and you are in control of how you want to release the package. To enable a great continuous delivery, continuous deployment story also in such a scenario, we have introduced a technology called App Installer, which enables to have automatic updates even if the application is deployed through a website or a network share. So with the App Installer technology, you publish your MSIX package on a website, for example, and together with the package, you publish a XML file like this one with App Installer extension. And inside this App Installer file, you can set up some parameter, including a section called Update Settings, which contains the various settings for the automatic update story. You can enable automatic updates every time the application starts. You can check for updates in the background. You can have updates which are critical and they can't be postponed, and so on. When the user will install the application, he will do it from this App Installer file using a special protocol called MS App Installer. Once they have installed the application, Windows will link the package to this URL. And so when you want to release an update of your application, you will just need to publish in the same location, so in the same website or in the same network share, an updated MSIX package, an updated App Installer file, and that's it. Windows, based on the update settings you have defined, will start triggering the update experience based on the logic you have defined. Another important part of the story is the signing process, because since MSIX packages are trusted, to make sure that the users can't install malicious packages, applications must be trusted. So there's no way to install an MSIX package on a machine if the certificate used to sign this package is not trusted, or even worse, the package is not signed at all. You have the option to sign the package with a certificate coming from a public certification authority. This is the best option if you are opting in for a wide distribution. If you are opting in for an enterprise distribution, you can also use a certificate coming from a private certification authority internal in your enterprise. These are the best certificates because they are trusted by Windows 10 by default. So the user won't have to do anything special to deploy the application, to install the application. You can also use self-signed certificates, but they are a good fit only for development or testing because they are not trusted by Windows 10 by default, since they don't validate the identity of the user. So as a user, I need to trust the certificate to install the application. So the installation experience is not very straightforward. And in some cases, it might even be a blocker because to trust a certificate, I must be administrator of the machine. The best practice is to sign packages is to don't use Visual Studio. Visual Studio offers you the option to sign the package as part of the build process, but to achieve this goal, you would need to share, to upload the private certificate, the private key to your repository. And this is a bad idea because any person who has access to this repository basically would be able to to steal the certificate and reuse it to sign other application. So the best way, the best approach is to sign packages in the release pipeline. This way you don't have to share the certificate with the repository. Which are the ways you can use to sign the package as part of your release pipeline? One option is to use a certificate, a task called code signing, developed by Stefan Kurt, which basically is using under the hood the sign tool utility, which is part of the Windows 10 SDK. With this task, you can choose the certificate, the private certificate you want to use, you share the password, you choose the MSIX package you want to sign, and that's it. This task is safe because it uses secure files to store the certificate. Secure files is a feature of Azure DevOps which allows you to upload a file, but then this file can be used only in the pipeline you choose. So when you share your private key with this task with using secure files, no one will be able to download the file, including yourself, and you will be able to use the certificate only in the current pipeline. So this way, even if you share the project with other people in your company, no one else will be able to reuse the certificate for signing other applications. If you want to have better security, you can also use Azure Key Vault. Azure Key Vault is the service provided by Azure to store in a safe way passwords, secrets, and certificates. You have two options. The first one is that Azure DevOps is able to connect variable groups to Azure Key Vault. So you can use variables inside your Azure DevOps pipeline, but the value of this variable is not coming from Azure DevOps itself, but from Azure Key Vault. So you can store the password of your certificate on Azure Key Vault, and then in the task, in the signing task, you can set up as password a variable coming from Azure Key Vault. So this way, you don't have to share your password with Azure DevOps, but you can leave it on Azure Key Vault. If you want to have the maximum security, you can even store the certificate in Azure Key Vault. You don't store the certificate in Azure DevOps, but you do the signing using a .NET Core tool called Azure Sign Tool. This tool works like the Windows Sign Tool, but instead of getting the password, the certificate locally, it can connect to Azure Key Vault. So in the command line, you can set up the connection to Azure Key Vault. You can add, you can set up the URL of Azure Key Vault, your token to access to Azure Key Vault, and that's it. The tool will take care of going to Azure Key Vault, getting the certificate, and signing the package for you. Let's see an end-to-end demo of what you can achieve once you have implemented a full continuous integration, continuous delivery pipeline. So here I have a website. This is an Azure Storage static website, but it can be any website, where I have published my MSIX package with the app installer technology. So when I click on Get the App button, I can trigger the installation of the application through the MS App Installer protocol. You can see that the Get the App button is linked to the App Installer file using this special protocol. You can immediately see that the App Installer provides a different experience compared, for example, to NMSI. When I click on Get the App, I'm not downloading an installer that I need to manually install later, but Windows automatically triggers the installation experience for me. So now Windows is automatically downloading the bits from the app installer from my Azure storage. And it's also automatically understanding which are the right files for my configuration. For example, I could have an MSIX bundle with multiple packages for multiple architectures. Windows will download only the bits for my PC, which is running Windows 10 64 bits. So now I have my WPF application running on my computer. Let's say that I received the feedback that this blue background is very hard to read. So I want, my users want a different color. So let's go to Visual Studio and let's change this color. This is these are the global XAML resources of my application, and this is the solid color brush which defines the blue color. So let me change that to red, for example, and let me commit the change. So change it background to red. Now I'm pushing the changes to my repository, and since I have a continuous integration pipeline set up on Azure DevOps for this project, what happens is that if I go to my pipeline, I can see that the pipeline has kicked in. So now there's a build happening on Azure DevOps for my application. This build will take care of compiling my WPF application, and since I have the Windows application packaging project, this will generate an MSIX package for me. So now, once the build kicks in, you will notice that there are multiple tasks, but the core task for my experience is the task, the Visual Studio build task, which is the one that takes care of running the build. Meanwhile, we wait for the, okay, you can see that now the pipeline has started. So now you will see the different tasks kicking in. The core task is the build one, which is the one that just runs a Visual Studio build with the various parameters. Meanwhile, we wait for the build pipeline to complete. Let's see a little bit the continuous deployment story, so the release pipeline. One of the biggest strengths of Azure DevOps is that it provides a great release management story. So I can build not just a release pipeline, but a whole release management story to decide how how and where I want to deploy my artifacts, my output of the build pipeline. So in this case, you can see that I have a couple of different environments, test environments and a production environments, where I want to deploy my MSIX package. And I can set up different conditions. So for example, the testing environment doesn't have any specific condition, because I want to make sure that every time I generate a new MSIX package, I want to deploy it right away on my testing environment. However, my production environment is more important. I want to keep it under control. So in this case, I set up a pre-deployment approval. In this case, it's me, but it could be the owner of the project, someone from the management. So before deploying to the production environment, I need someone to approve the workflow. Otherwise, the package is not deployed. I can also enable gates, so I can have some automatic checks to validate the deployment of my application. For example, I can check that I can use a tool to validate that there are no known vulnerabilities in my libraries. And if this is the case, the deployment shouldn't happen. Or I can check if on my Azure board, I don't have any bug open, or on GitHub, I don't have any issue open for this specific release, and so on. If we take a look at the tasks that my release pipeline is doing, it's essentially two things. The first one is the code signing. As I said before, the best practice is to do the signing inside the release pipeline. So here I'm using the task, the code signing task, to sign the package generated by the build pipeline. The other task is the deployment one. In this case, as I mentioned, I'm using an Azure storage with static websites. So I'm using a task called Azure Blob file copy to copy the output of the signed MSIX package to my blob storage. So now if we go back to the pipeline, we can see that the the pipeline has completed. And now I have two artifacts. I have an artifact in my pipeline, in my project. So the pipeline has generated a MSIX package, an MSIX bundle. So this is the main application. I have the app installer file, which contains the information I need to trigger the installation. And then I have also a web page, which Visual Studio automatically generates for me, which is the page we have seen before. So it's this one that I have used to generate my, to trigger the installation of the application. So now if we go to the release pipeline, we can see that the deployment is already in process because I have enabled my release pipeline to automatically kick in when a new artifact is ready. So now the pipeline is taking care of signing the package, and then it will take care of doing the deployment on Azure storage. So the package has been signed, and now I'm transferring the package from Azure DevOps to my blob storage. So let's wait for a few seconds for this operation to complete. Okay. Now, if we go to the website and we refresh the page, we can notice that the version number has increased from 1056 to 1057. However, as a user, I don't have to come back here to get the updates, since I have enabled automatic updates through the app installer file. So all I have to do is open again my application. Windows is checking for updates. He will find a new package deployed in the same location from where I've installed the application the first time. And it will tell me, hey, there's an update. Do you want to finish the update? Sure, go on. And now you will notice that the update process will be faster than before because Windows supports for MSIX differential updates. So it's downloading only the files that have been changed compared to the previous version. However, as a developer, I didn't have to do anything special. I just generated a new MSIX package with the whole application. And now I have my WPF application with the red background. So I've been able to move from a changing code to the application deployed to my customers without any manual intervention, either from a developer point of view. So I didn't have to do anything else than committing the new code to my repository. And as a user, I didn't have to do anything more than opening my application and letting the auto-update feature to complete its work. So in this short session, you have seen the three important steps to enable the DevOps story, a DevOps story for desktop application by using MSIX packages and app installer to have automatic updates even without the store, and to use Azure DevOps to take care of the building, release management, the signing of the package, and so on. I've left in this slide some resources to go through the technologies we have seen so far. So MSIX, Azure DevOps, how to create pipelines for desktop application. And you will find also a couple of links for a couple of features that I didn't have time to show you. The testing story, UI testing with WinUpDriver, and Visual Studio App Center to adding telemetry, which are testing and telemetry are two critical parts of the DevOps story, to have a solid DevOps story. So thanks everyone for following us so far. And these are my contacts. Feel free to reach me out and also to leverage the TAP Yammer group if you have any question. Thank you.
Thank you, Matteo, and thank you, Mike and Sebastien, for this wonderful presentation. And thank you, everyone who joined this session. So just a reminder, let me share my screen. Just here it is. So yeah, just as a follow-up, please remember to follow up in the Yammer group. We have this AKA link for questions. If you have them right now or after you watch the session on demand, feel free to ask the questions over there. We will be monitoring that Yammer group and answering the questions over there. If you want to follow up on a one-on-one on any of these technologies, or you would like to see this in action or to work together in one of your projects, just let us know. Send us an email to deptap@microsoft.com, or just add it to the Yammer group, or reach out to our different LDS that we have for the TAP program. So with that, thank you so much, everyone, for joining. Stay safe and good rest of the day to everyone. Thank you, Matteo, Mike, and Sebastien.
It was a pleasure. Thank you.
Thank you.
Bye.
Bye.